tonight. It's just been little jobs again. I'm still waiting for the magneto and some other parts to come from the UK. I did order some more things today. I've been having a look at what a period correct choke cable or choke control would look like, and I found an example picture online of a period Riley instrument panel, and it has a little sort of Bakelite knob. The example I saw had the text, I think it was pull rich on it to mean enrich in the mixture, and you can still get those. So I ordered one of those off eBay, and they're designed to fit onto the Lucas 1/4 inch hex shaft heater and choke controls. And it turns out those are used in Triumph TR2s and TR3s. And I was able to buy one of those as well. They're not cheap, but nothing on this is cheap. So that will give me the period correct choke control. It won't have to go very far. So it just has to link from here to the instrument panel. And another part arrived, which was my fuel pipe union there. So this is now soldered onto there, so I can join whatever I need to onto this. I will probably need some sort of anti-vibration loop in there, or else use a piece of rubber hose or something. So that's all looking good now. And I've been thinking about the issue of how to turn the engine over when you can't really get to anything. And my dynamo does have provision for a starting handle, which I don't have. So when I was playing with the dynamo and testing it, I used this piece of thin wall tubing on a drill, and I was able to spin the dynamo with that. So what I've done tonight is I found a piece of steel just out of the scrap box, and I've machined up a little driving dog type thing. A little focus on it. Here we go. I'm not sure what that steel is. It didn't machine that nicely. It seems very hard. So I don't think it's just mild steel. But this is basically a little cylinder, and it's got a stem on here, which is how it's attached to this other piece of tube, this hollow tubing, 1/2 inch tubing. And I just milled a slot in the top and bored it out to make sure it actually goes over the end of the shaft and the bolt on the end of the shaft, and that it goes down deep enough to actually engage in the dogs. The tubing I just bent on my little tube bender thing, and I'm not going to actually use this as a starting handle, so I kind of made it as big as I could, and this actually worked out to be effectively as big as I could make it and as small as I could make it, because I can't get the bends any tighter than this in the machine. This is just a sort of push fit into the tube, and again I'm using my Loctite 638 to effectively glue that in there, and I want to see how strong that actually is, if it's strong enough to let me rotate the engine once this is set up. So this stuff actually takes about 3 days, I think it is, to fully cure and get fully solid. So I'll leave it for a little while before I try using it. And I got some parts that I was going to use to look at removing the play in the top shaft and the gearbox. So the first thing I got was a speedy sleeve. That's a 3/4 inch sleeve, but they're too short. And also it doesn't fit over the splines. So I couldn't, it might fit over that end, but it's quite tight. Then I realized in my junk box I had a 3/4 inch bush, and then I bought the slightly smaller diameter bush on the other side. And this is my spare shaft for the top shaft that I've got. I've cleaned that up, just wire brushed it. And there's still a little bit of wear, because there's actually also a little bit of wear on the shaft, but that's way better than what I've got, and this end is nice and solid. So my thinking is, because I've got no way of machining this accurately, because I don't have any datum points, I think what I'm actually going to do is very carefully hand file or sand this out on the end here to be big enough to get the bush in this end and also down in this end. If I do it very carefully and very gently, I should be able to get it so that the bushes are almost a push fit in there, and that Loctite will take up quite a big gap. I think it's about a 0.5 millimeter gap all the way around. So what I'm hoping is I can make it a nice enough fit that it pushes in, slides in, but there's enough wiggle that I can then Loctite those in place and put the shaft in place to make sure everything stays aligned and have the Loctite take up the space around it. This side isn't actually too bad. I may be able to get away with not actually doing that side. You can sort of see there's a little bit of wear there, but I think if I'm going to do one end, I might as well do both. This other end, I don't know if you can see. Let's tip that down. It's pretty bad. And that amount of movement there translates to at least 3/4 of an inch on the end of the clutch pedal. I've also been looking at that and my linkages and things here. And what I've discovered is I've got 3 holes in here. I wasn't sure exactly where it needs to go. Of course, shifting the position changes all the leverage on the whole system. And what I discovered is the 1/2 inch holes here give me effectively an 1/8 of an inch movement on the release cup here as it comes back. And this hole here will give me the full movement of this before it actually binds up in here or it hits a limit inside here. So I'm pretty confident I've got this in the right range now. Exactly which hole I'm going to use, I'm not quite sure yet. And I've also been looking at how in a real Brooklands the pedal movement is limited. So you don't want it falling all the way forwards there. On the saloon cars, there's a spring that goes from the pedal up here back, which is pulling the pedal forwards. On mine, I'm going to have the spring at the bottom. You don't actually need a very strong spring there. You just need it to be able to lift the pedal up. But you do need some sort of stop to stop the pedal coming all the way forwards. And another Brooklands building friend of mine and I were looking at this, and between us we've got quite a few different photos of original cars and replicas and things like that. And one of the common ways it seems to be done is there's actually a flat floor that goes in here when the car's finished. So it sits on top of this cross member. This is kind of where you rest your heels, and you can see it, even because of the way the cross member works, it'll fit under the chassis rail there. So what we've seen on some cars is on that flat floor, we just sort of imagine that's level, there's actually a little stop, a little right angle plate that comes up, and the floor is slotted, or the plate is slotted, so you can slide that backwards and forwards and then bolt it up tight, and that lets you set the rest position of the clutch. You can sort of see there, that's effectively the wear. They're about there. It's hard to show exactly, but you have that on the clutch and the brake pedal, so that might be a neat way of doing it. I think, as I've mentioned before, another way I've seen is where there are fingers that come off here and are sort of bent around, so they kind of hold it like that. I've also seen another one where there's some sort of arm that comes off here, a wire that the clutch pedal can rest against. So there's various ways of doing it. What's actually factory original is really hard to know, because these are nearly 100-year-old race cars and they've all been modified over the years. So knowing what's correct or factory correct is really quite difficult. So that's where I'm at on that. And I've been doing a few other little bits and pieces, but they're actually in the lab, so I'll go in there to have a look at those. So out in my little lab, which is a mess, once again, I've got various little bits and pieces I've been playing with. First, thanks to Michael, who sent me a couple of these old Smith's gauges to play with. And I haven't actually got these working yet. The gauges come with this special sender thing, which I haven't really figured out exactly how that works. So it's a mechanical to electrical drive, and I believe they use these on commercial vehicles, 50s and 60s commercial vehicles. So I do need to figure out exactly how that's supposed to work. But I'll leave those for now. I did buy this replica big gauge. These, they're not cheap, but they're cheap compared to the real ones. These are sort of electronic. There's actually a switch on the back so you can change it for how many cylinders you've got. And what my thinking was is I could use this and change the face of it to make it a bit more vintage, or at least change those crosshead screws to something more period correct. But unfortunately, the bezel is actually rolled on, the edge is rolled over, so I would have to either mount this in the lathe and very carefully machine that off to be able to get inside there. It's not like the proper Smith's type gauges where there's little tabs on here and you can usually rotate the bezel and then it'll pop off. This is sealed, which is a little bit annoying, but it's okay for now, and it's not terrible. So it's an electronic tack, and I've made up a little circuit just using an Arduino and a potentiometer, so I can vary the needle position. So this is very crude at the moment. This is just a basic sort of thing. I actually have it, the scale isn't correct the way I've got it set up. So the way I've got it set up is the knob is actually going to 8,000 RPM, which is off the end of the gauge here. This is actually about 6,000 RPM, which is why I was looking at changing the face, because I can calibrate this to whatever I want and just create a suitable face to match and etch that or print that. So that's why I wanted to be able to take the face off. This would work in a car with a coil and just by itself. I'm playing around with the microcontroller because I don't have a coil, I have a magneto, so I'm going to need to get the signal from a spark plug wire and use that to drive something like this. This is what I'm playing with. I'm not sure how well this idea is going to work, but it's fun to play around with. I haven't done any electronics for a while, so it's always been a hobby of mine, so it's fun for me to go back and do little electronics projects now and again. But what I ended up doing was buying one of these, oops, losing my scope probes, cheap, like very cheap, couple of dollar sort of thing, electronic tachometers off AliExpress. Trade Me have these, eBay probably have them, and basically what it is a little electronic unit. It comes with a wire, which is just a long black wire that you wrap around a plug lead, and it will give you an RPM reading on a little display there. And they come with a soldered on battery. There's a little 3-volt battery which is soldered in place. You can't change that. Well, you can't easily change that. Obviously, if you can desolder it, you can solder in a new one. And I've just temporarily wired it up with 2 AA batteries. And what I've discovered is we hook the oscilloscope probe up to it. It's a bit tricky with one hand. So here we go. Obviously, I don't have an engine in here I can hook this up to, although I could actually do that, but let's not do that. So this is the probe wire. What I've discovered is you can use a piezoelectric lighter, and that will actually give enough of a pulse to trigger this thing. So if we set this up, it's kind of automatic what it does, but without setting anything on fire. I can't do it very regularly. Turns out these things break really easily if you just keep flicking them on and off like that. But I think you can see I had actually emptied all the gas out of this, but the resolution on the meter isn't very good. You can see the minimum it gives you is 60 RPM, so effectively a pulse a second. But given that that works, I looked at the back of this, and you can sort of see the circuitry there. This will just be a microcontroller to drive the display. This is a 74HC series quad NAND gate, and I was able to trace out the rest of the circuitry to figure out how they were doing the triggering, and it's actually relatively simple. Here's my very messy diagram of how it works. There's just basically a transistor capacitor to decouple the input from the trigger wire, and then the quad NAND gate is set up to do some basically generate a pulse. So we should be able to see that up on the oscilloscope. So that's generating a pulse. Every time I click the trigger. So that's what's cleaning up that pulse. Oops, my lighter was stuck on. So after I reverse engineered it, I built up my own version on a little breadboard here. I don't have the exact same transistor they're using, so I've just substituted one, and that seems to work fine. Rather conveniently, this little circuit board has the component values written on it, which is really good. It made it really easy to figure out what was going on. And if we swap this over, again, this isn't easy. Can't even find my output wire. There we go. So I now have it hooked up to my other little circuit, and I've got just a very short trigger wire here, and it works. Let's see. I think my lighter has given up the ghost. Oh no, here we go. My component values might be a little bit off, which is why the pulse isn't as long, but that's all tunable. But that actually gives me a nice pulse. So at the moment, these two circuits aren't connected, but now effectively all I need to do is hook my pulse output from here to an input on the microcontroller, write a little bit of code, and convert that into a signal to drive the tachometer here. So that'll be the next step. It'll be interesting to see if that works and what I can do with it. And the idea then is I would build all of this into a robust container. It's probably going to need quite a bit of filtering because the electrical noise in a vintage car can be quite bad. I'm not sure how that'll affect the microcontroller. Everything would obviously have to go inside a shielded box. But the idea would then be I can build a little tachometer that just needs a couple of turns of wire around one of the plug leads to pick up the signal. So that'll be the next step. If I can get the face off this gauge, the actual electronics and the needle, the meter movement inside here is going to be pretty small. So there's actually room to fit everything inside there. One of the things I did look at doing in software was simulating a chronometric tachometer, but it's actually very hard to do with one of these analog type movements because the needle can't move fast enough. So you don't get that real twitchy needle movement that you get on a proper mechanical chronometric tachometer. I do have a chronometric speedometer, which will be going in the car, a proper period correct one, which seems to work. So it's kind of where I'm at on that. So tomorrow's job will be trying to do the code to convert the pulse into an actual rev reading. And then if that works, I'll make this a bit more solid and actually test it out on an engine, I guess. I've got the Austin 7 or the Riley, not the Riley, the MG, or a lawnmower even. They should all work pretty much the same.